Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua dan semoga kita semua selalu disertai perlindungan dan keselamatan oleh Allah Subhanahu wa taala. Sebelumnya perkenalkan, saya Lista Putri Adinda Rahmi NIM 09191038 dari Prodi Teknik Perkapalan kelas B Teknologi Las dan Korosi absen 22. Di sini saya akan memaparkan sedikit materi tentang teknik pengelasan yaitu adhesive bonding. Sedikit pengantar dari saya, jika kita membahas tentang penggabungan dua materi atau plat, maka hal tersebut bukanlah kegiatan yang mudah. Kita harus paham bagaimana metode pengelasan yang tepat sesuai estimasi waktu, biaya, juga kemampuan teknikannya untuk melakukan pengelasan tersebut. Untuk itulah dicari alternatif lain selain dengan menggunakan pengelasan. Salah satunya yaitu dengan menggunakan adhesive bonding. Berikut pemaparan tentang materi adhesive bonding dari saya.
Some of the old songs. For old time's sake. As time goes by. Been a long time. For old time's sake.
I don't know what you mean, Miss Elsa.
Adhesive bonding, like welding, provides a distributed means of transferring load from one part to another. We can eliminate the stress concentrations induced by fastener holes and spread the load transfer out more evenly over the joint, making it a very attractive joining option. However, rather than relying on the melting and fusing of the parts as with welding, adhesive bonding uses an additional material to glue the two parts together. This can eliminate some of the material restrictions encountered in welding, but introduces its own set of challenges to deal with. An adhesive bonded joint relies on an adhesive material to join the two parts together. If we look closely at how this adhesive material connects to the parts it is joining, we can see that two different mechanisms for transferring load come into play. First, the adhesive material forms a chemical bond with the part it is joining. These chemical bonds and their strength will be dependent on the bonding process and the compatibility of the adhesive and joining material. Second, the adhesive material will flow into the nooks and crannies of the microscopically rough surface to be joined. The adhesive will then mechanically interlock with this surface roughness, allowing some load transfer through mechanical interlocking. Realizing this, let's take a closer look at the possible failure modes of an adhesively bonded joint. If we zoom back out from the joint and think about how such a joint can fail, it is possible to envision three major categories of failure. If the load exceeds the strength of the material being joined, you have failure in the joint material, known as adherent failure. Like with mechanically fastened joints, this is a desired failure mode as it means the joint is sufficiently designed to reach the strength potential of the structures it is joining. If the load exceeds the strength of the adhesive, then the adhesive material can fail. This failure mode is typically referred to as cohesive failure, as the chemical bonds that hold the molecules together within the material are known as cohesive bonds, and it is these bonds that are overcome to cause the failure of the material. This failure mode is limited by the strength of the adhesive material. Conversely, if the chemical bonds that glue the adhesive material to the part being joined are overcome by the loading, failure can occur along the interface between the adhesive material and these parts. This failure mode is known as adhesive or adhesion failure and is limited by the quality of the chemical bonds formed during the bonding process. This failure mode is not acceptable for aircraft structures, and if occurs, it is a sign that there were problems with the bonding process itself. It is important to understand the basic steps within the bonding process in order to understand the potential risks for adhesion failure in a bonded joint. If we start with the two parts to be joined, the first critical step is to prepare the surfaces of the parts. This surface preparation step can involve one or more of the following: increasing the roughness of the surface using an abrasive material such as sandblasting, cleaning the surface using industrial solvents to remove any grease or impurities, and using a chemical process to activate the surface of the part, making it more prone to form chemical bonds with the adhesive material. The next step is to apply the adhesive material to the parts to be joined. The adhesive material can come in many forms, including an adhesive film or paste that can be applied on the surface of the part. Once the adhesive is applied, the parts can be assembled and temporarily held in place with some form of clamps or fixtures. This is an important step as the adhesive cannot carry loads until it has fully cured, forming all the necessary chemical bonds with the surfaces of the parts. The final step is the curing step. In order to speed up this process, it is common to apply heat and pressure to the part, which will accelerate the chemical reaction within the adhesive. In aircraft manufacturing facilities, you will often see large pressure ovens known as autoclaves, which are used for curing adhesively joined parts and composite materials, which are essentially adhesively bonded structures. From the description of the different steps within the bonding process, it should be clear that the surface preparation step is vital for ensuring the quality of the bond. Impurities and insufficient activation of the surface to be bonded can result in a very low adhesion strength of the joint, which is unacceptable for aircraft structures. Unfortunately, one of the challenges we face in the aerospace industry is that the pretreatment processes we use tend to involve toxic chemicals that are not good for the health of workers or the environment. We are constantly trying to find more environmentally friendly options, however, these tend to have a significant reduction in performance. The second major challenge is that the repeatability of quality in the bonding process. You might have inadvertently encountered this before if you have ever used adhesively backed sticky notes. If you put a number of sticky notes on a wall, being sure to try and repeat this process in the same way for each note, you will notice over time one or more of these notes may fall down. It is easy to say that contamination or small variations in the process resulted in the premature failure, but predicting which note will fall first and when it will fall is extremely difficult. This inability to precisely predict when failure may occur makes certification of bonded structures very difficult for safety-critical structures. So adhesive bonding is a chemical process that can result in a very efficient structural joint, but is susceptible to pretreatment and processing variations. Although as engineers we would like to exploit the efficiency of bonded joints much more, in practice, the challenges associated with process variations make it very difficult to make widespread use of the technology for primary structural joints.